Hello and welcome to our exercise with this thing here. This thing is an ultrasonic device. What does it mean? How does it function? There is a thing called marked with T, there's a thing marked with R. This is basically a loudspeaker and this is basically a microphone. We can trigger an ultrasonic impulse from here. Then this ultrasonic impulse gets reflected somewhere, and will return to here. The farther away an object is which reflects the sound, the longer it will take to return. So that's the basic principle. You see on the bottom we have got four pins. One is marked VCC, there we can connect the 5 volts. One is marked ground, we have to connect the ground. One is trigger and one is echo. The trigger pin will trigger the sound and the echo pin will be high as long as the sound needs to return. So in order to know how long for the ultrasonic thing it took to come back again to our sensor, if we just have to measure how long the echo pin was high. That's it. This thing looks really somehow spacey. However, if you place it in a decent, this here is a self-printed case, then it already looks pretty solid and rigid. There's nothing else inside than this here. It's just printed out. This one I'm using to measure this was the prototype. There you can see exactly how this was designed. It was just some parts. On the background, on the back you see exactly the sensor. It's exactly this sensor, and there I just placed this tube, and with the help of this tube I can now put into a water glass or whatever, and the water inside the tube will raise and fall, and I can measure the distance to the water and the level. And this was, like I said, the prototype. If this is really working with this wood thing, and this one is the printed, still a prototype of course, but it looks already much better. And there's also the tube fitting in, and this looks already pretty much like a measurement device. Okay, but basic is this here. Now let's see how to connect this. Like said, we have to connect 4 pins. There is power supply, I will make it red again. There is the ground, I will make it brown again. And there are the 2 trigger and echo pins. Trigger is now, come on. Okay. Did not destroy anything, I hope. Okay. Trigger is yellow, echo is orange. Then of course I have my Arduino. I will plug in plus in 5 volt. I will plug, this is not plus, this was the ground. 5 volt. And I will use trigger and echo, and I will use the trigger on pin number 2 and echo on pin number 3. Okay, that's the measurement. Now it's just to trigger an ultrasonic impulse here on the yellow line, measure how long the orange line is high, and then I know what the round trip time was. Let's try to program this. Again, I start by saving it under a proper name. It's 36 already. I will call it distance. Distance measurement. Okay, so I'm again defining my pins. Define the trigger pin. This was pin number 2, and of course have the echo pin. This was pin number 3. Of course I have to set the pin modes. Okay, so I'll also begin again my serial with 9600, and I have to set the pin modes. Pin mode, and the trigger pin is an output, of course, output, and the other pin is an input. The echo pin is an input. We do not have to need to use input pull up, because this thing is doing it, setting it to high and low as we expect. So this is working. Okay, then to get the duration, I will also again write a proper function. Unsigned long. This is my return code. I want to get the direction in milliseconds. Okay, get duration. How to get the duration? Duration means the duration, how long was the round trip time. I have to go sure that on the trigger pin there is a pulse. Okay, digital write. So write the pulse simply. Yeah? I will use the trigger pin and set it to low. Even if it was high, for whatever reason, it's now low. And then I will delay for 2 microseconds. Should be enough to realize for the module that this trigger pin is low. Then I will set it, then I will set it to high. And then I delay 10 microseconds. This is enough to realize for the module that this is a pulse. Okay, then again I have to set the trigger pin to low, and that's it for me for the trigger pin. Okay, and then I simply have to return, and then there's a function pulseIn. Okay, it measures the duration on the echo pin, how long it is high, and here 1000 milliseconds is the maximum, I would say. 1000. 1 second would already be pretty far away. We don't have to wait for answer longer than 1000 milliseconds. I mean, 1 second speed of sound, 330 meters or something like this, 343. No. We can measure up to 4 meters here. This is the maximum. Okay, so then in the loop I just have to measure. So unsigned long duration, and I will call this get duration function from which I just wrote. If duration is not 0, then I can print out the duration. I will simply say serial.print measured duration, serial.print duration and serial.print its microseconds. Okay, microseconds. Else we have not received any echo. No echo received. Okay. So up to 1000 microseconds, just as before I said milliseconds, right? Microseconds, this is microseconds, of course. No echo received, and then we have to delay the next measurement. We will make in half a second. Okay. See, pin modes are defined, serial is defined, function get duration is defined. We measure and print out the duration. Upload. Of course, problem uploading. Why? Because I did not plug the hardware. Bim bilim. We are on load, we are online. Now we can upload and open the serial monitor and see what it's printing out. No echo up to now. No echo received. So I will just use here my ruler. Just use my ruler and see if I can produce an echo. Okay, this does not look too good. Yeah, I'm writing everything in one line. Why? Because I have to write here print line, of course. Yeah. Upload. No echo received. 301, around 300 microseconds. If I move now closer, you see, it's less. It's 180 right now. If I move far away again, I'm around at 300 again. Working nice, right? So I can distinguish how far we are away. By the way, this is your task. You don't need to print out the microseconds. I want to see how many centimeters I'm away. Okay. This would be your task. So this is how it should look like. I will again use my ruler. The distance should be given in centimeters. If I move closer, of course it should get less. If I move far away, it should get more. See, 10 centimeters, maybe accurate. But that's another story. Calibrating the thing. Good, right? This is how it should look like. No echo received. Good, yeah. So that's distance measurement by sound, ultrasound. Okay. Think about how you achieve this from a duration that you can get the distance. Next time we are going to talk about level measurement with a different approach. We will use a level sensor which is inside our starter kit. For this time, thank you very much for listening. Goodbye.